Professor. My name is Gautam and I'll be explaining the second problem of the homework 6. So we are given that we are told that fxy of x comma y is equal to a, and the limits, and we are told that x square plus y square is less than or equal to 1. So in the first part we have to find the value of a. Now since we can see this as this is the equation of a circle, and so we can say that y ranges from minus of root 1 minus x square and to root of 1 minus x square, and x ranges from minus 1 to plus 1. So when we integrate this, we get the value, that is fxy of x comma y, and in the limits root minus of root 1 minus x square to root 1 minus x square, and x from minus 1 to 1. So first we integrate this with respect to y, and we get the value as 2 times root 1 minus x square, and we simplify this, and again we integrate this with respect to x. So basically when we integrate this, we get the value as root of 1 minus x square into x sine inverse of x in the interval minus 1 to 1. So basically this will be always 0, since this function will be 0, and sine inverse of x for 1 and minus 1 can be pi by 2 and minus pi by 2. So when we add that, we get the value as pi, and when we simplify this, we get the value of a as 1 over pi. In the second part, we have to find the value of expected value of x, xy, and y and xy. So for e of x, we say that since we don't know the uh, expected value fx of x, so we can do it as double integration of x into fxy x comma y dx dy in the limits minus infinity to plus infinity for both. And since we have already calculated this with respect to y, we get this of 2 root of 1 minus x square as we just did above. And again when we integrate this, but here we know that x root of 1 minus x square is an odd function, so this will always be equal to 0. Therefore the expected value of that will be equal to 0. Now similarly we can say that the expected value of capital X over small y is equal to 0, and since e of x is 0, and similarly the expected value of capital X over y is also equal to 0. Now, since as the given function is symmetrical, we can say that the expected value of y is also equal to 0, and the expected value of y over small x and expected value of y over capital X is also equal to 0. Now for e of xy, we again integrate xy fxy of x comma y dx dy in the limits minus infinity to plus infinity again. So that is xy dy dx from minus root 1 minus x square to minus 1 to 1. So basically this should be xy. So dx dy 1 over pi, and so basically first again we integrate this with respect to y, but we know that this will be an odd function. So e of xy again will also be equal to 0. Therefore, now for the c part, we have to prove or disprove whether x and y are uncorrelated. And for to prove that whether x and y are uncorrelated, we have to show that e of xy is equal to e of x into e of y. Now from above we have seen that e of xy is equal to 0. E of x is also equal to 0 and e of y is also equal to 0. So therefore e of xy is equal to e of x into e of y, and thus x and y are uncorrelated.